right here, I'm looking to get x by itself. So here's the equal sign. I want to get rid of this, and I want to get rid of this. So the first thing I'm going to do is say, okay, I want to get rid of this minus 5, so I'm going to do plus 5, right? I always deal with addition and subtraction first before multiplication and division. Okay, so I bring down x over 4. Negative 8 plus 5, I have more negatives than positives, and then I'm subtracting, I get 3. This says x divided by 4, so I'm going to go ahead and multiply by 4 to get rid of it, and I get x equals negative 12. Miss Broderick has 40 pencils in the cup at the beginning of the year. Each day, 5 mysteriously disappear. Like, where are they going? Are you eating them? Write an equation in slope-intercept form. Here's what we need to know. Whenever I read a question like this, where there's a starting point and then a change happening, I know that I'm going to use slope-intercept. Okay? So in this case, my starting point is that I have 40 pencils in the cup, right? I'm starting with positive 40 pencils. Now what's happening each day? 5 disappear. Is this number going up or down? It's going down. I'm losing 5 pencils each day. Rearrange this into slope-intercept form. Okay? Now listen, be careful. You got to read the directions because this one says rearrange, but it doesn't always say that, right? Like sometimes the directions will say find the y-intercept or find the x-intercept. So just make sure you're paying attention to what the directions say. In this case, I'm rearranging into slope-intercept form, right? That's this. So I want this equation to look like y equals mx plus b. So I want to leave the y, get rid of everything else. So I'm going to start by getting rid of this term that has x's in it. I'm going to bring down, look, don't forget to bring down this negative. These are not like terms. I'm just bringing down this term, 5x, and this term, negative 8. Now I'm going to divide by negative 4 because y is being multiplied by negative 4, and I want y by itself. So now what do I get? Y equals positive divided by negative is negative. 5 divided by 4 will give me a decimal, so I'm just going to leave it as a fraction. That has an x on it. Negative divided by negative is positive. 8 divided by 4 is 2. Okay, I'm graphing this. I have 2 choices. I can do what I just did right here. Totally fine. Go ahead and try it, right? If you're like, oh yeah, I like that, go ahead and do that, okay? The other option is I can find the y-intercept, and the way that I do that is I plug in 0 for x, right? And look what I get, right? This cancels, and then I end up with 3y equals 6. I get y equals 2, so that's x is 0, y is 2. And then I can find the x-intercept by plugging in 0 for y. Okay, now look what that looks like. This is negative 4x equals 6, so I'm dividing by negative 4. Positive divided by negative is negative, and 6 divided by 4 is 1.5. Okay, so this gets me x is negative 1.5, y is 0. Okay, so this is, this is pen not working out for me. This is 0, 2, not sure why it looks negative. And this is negative 1.5, 0, right? Which is right between 1 and 2, negative 1 and negative 2. So my line looks like this, okay? Now say I had decided to rearrange it. In case you tried that, I'll just write what you would have gotten. You would have gotten 4/3 x plus 2. So you would have started here at 2. You would have gone up 4 over 3, put a point right there and drawn the line, right? That would have been totally fine as well. Okay, solve the system. I notice here I have a y by itself, and I have an equation in standard form, right? One in slope-intercept, one in standard. So what I'm going to do is I notice this y is the same as this y, is the same as this. How do I know it's the same as this? Because this equal sign means this and this are the same, right? So here's what I'm going to do. I'm going to rewrite this equation in standard form, and instead of y, I'm going to insert something that's the same as y. Okay, so notice I've rewritten this equation, but I've only changed out y. Now I'm going to solve. I'm going to find my x value. I'm going to distribute first. I'm going to combine my like terms, right? This is 8 minus 2. Now I'm going to get x by itself. I have my x value, x equals 2. But remember, if I'm solving a system, my answer is going to be an x and a y. So I already have a 2, and I still need the y value. So I'm going to go and I'm going to plug this 2 back in. It doesn't actually matter which equation I plug it into, but this one's going to be easier. So I'm going to go ahead and plug this back in. I get 2 times 2 is 4. And 4 minus 9 is negative 5, so y is negative 5. And if you wanted to check it, you could plug the x and the y back into this equation here, right? You would get like this, negative 2 times 2 plus 4 times negative 5, and you would make sure that that equals negative 24, and it does. Graph the system. Y equals x plus 3. I'm going to start at 3 at the y-intercept, and then this slope is 1 over 1. So I'm going to go up 1, right 1, up 1, right 1, and then I'm going to just neatly graph. Okay, same deal here. I'm going to start at the y-intercept. Now the slope is negative 2 over 1, so I'm going to go down 2, right 1. Okay, and again, I can just sort of neatly graph this one. Okay, using a ruler would be a good idea. The solution is right here. That point is x value first, then the y value, right? Negative 2, 1. What I need to know here is that the x value is inside the parentheses and the y value is over here. So I'm being given the x value, so I'm going to go on the x-axis to 6. I'm going to find the graph, and then I'm looking for the y value, which is negative 2. I'm going to 2 on the x-axis. I'm finding where the graph is. It's right here. And I'm looking for the y value, which is 6. I'm going to negative 2 on the x-axis. I'm finding the graph, which is right there. I'm going up or down to find the graph. I'm finding the y value, which is 4. I'm going to an x value of 5, and then the y value here is 0. Okay, solve the system. I noticed that there's 2 equations in standard form, so right away I decide I'm going to use elimination. So what I'm looking for with elimination is, do I have for this variable or this variable, do I have 2 numbers that are opposites? And I do. Look, 4 and negative 4, oh, it's a gift. Those are going to cancel. When I add these equations together, this is going to be 4 minus 4, and this is just going to cancel right away. Sometimes I have to like multiply. Here I don't. Negative 3x plus 5x, that's the same as 5x minus 3x, that's 2x. 24 minus 32, I have more negatives than positives, right? And I'm subtracting. Okay, so 24 minus 32 is negative 8. And I divide by 2, I get x equals negative 4. Okay, so remember, with systems, I need an x value and a y value. So if I only have an x, I'm going to plug back in. It doesn't matter which equation I plug back into, but I'm going to go ahead and find y. So this is positive 12. Negative times negative is positive. Okay, divide by 4. I get y equals 3. Okay, and then I can just check it really quick. Okay, once again, it would be plugging in x to this bottom equation and y into the bottom equation. And I want this to equal negative 32. So like this is negative 20 minus 12. Yep, negative 32. Okay, looks good. Remember, this is the x value right here, right? This is the x value right here. That's the same x as this. So if I want x to be 2, then that looks like this. I make this x into a 2, and then I do the math. 5 times 2 is 10, minus 6, that's 4. If I want the x to be negative 5, look, this time, this tells me I'm getting the g equation. This one tells me go get the f equation and plug negative 5 in for x. So here's the f equation. I'm writing it, except instead of x, what am I plugging in? I'm plugging in negative 5. So do the math. Negative times negative is positive. I get 19.